Good evening, everyone. We have Mustafa Saifee sir with us. So he has done his graduation from IIT Mumbai, and his stream was electrical engineering. Then he has done his masters from Alto University. Right now, he is working as senior UX designer in Elvin, and he has a vast experience designing in complex applications and tool use in data-driven decision making. So we have so much to learn from you. So we would like you to hear from you. The floor is yours. Please share your experience and please give us insight so that we can become one like you as well. We are in that path. So yes.
Yeah, hey, thanks for the platform and thanks, Ankita, for inviting me. Yeah, so I'll just share my screen actually. Today, mostly we'll spend all time like discussing about data and how as designers we can like utilize data and make data like more interpretable and uh, more engaging per se. So a bit about myself, like mentioned, I'm currently working as a senior UX designer at Ivan, which is basically a database as a service company. And mostly my job there is to design like data intensive applications. So when we do that, like data visualization becomes like a key thing when you are doing UX for sort of data driven applications. And previously I was working in another IT consultancy called Futurist, where also I was mostly working as a data visualizer. And I've also worked with UNICEF with their some data platforms and stuff. Yeah. So the first thing is that let's start with like what is data visualization? So like the name suggests, it's basically the visualizing or the visual representation of complex and big data. And it's not about making something more interesting or more visually appealing. Like that's not the main aim of data visualization. The main aim of data visualization is to transform data or numbers into something which is more understandable, and you can extract more meaning out of it. So it's not about like making it pretty per se. So for example, you might see a lot of infographics out there which are like just representing one number but in a more prettier manner. That is not something which we focus in data visualization per se. It's more about like when you have a big set of data, how to visualize it, or use of graphics can help users to understand that data better and find insights from data or from that data better, basically. So why is it important these days? So as you might have noticed that data is everywhere nowadays. Like if you think about top 10 companies in the world are mostly like data platforms. So that's why it becomes like really important how we handle and manage this data. So there are two reasons I would say, like why is it very important? Because since we have so much data, so it becomes important how to visualize that. And since we are also the consumer of the data, it's always good to understand when a visualization is presented to you, is it presenting the right information or is it somehow misleading? So this also helps you identify when certain things might be certain visualizations might be misleading, when certain things are designed well, and when you're working as a designer, it becomes a responsibility for you that you don't deliberately or undeliberately mislead using data, using visualizations. So that's why it becomes like really important to like have certain idea. And from a market perspective, like if you think about it, the most in the market, the most common field, if you think right now, would be UI UX designers. And there also, if you think about it, data has become like the data platforms are the most common things which you will end up designing. So therefore, it's like from a career point of view, also it becomes like really important that you have a basic understanding how to use data and understand data and how to visualize it. Okay. And why what can visualization help you do is basically it can help you identify hidden patterns. in the data. So if you are given an Excel sheet per se, it might be really hard to just identify a pattern which is there, or identify outliers, or to see if something is going up or down with time or something like that. And visualizations are particularly really helpful and good in seeing those patterns and understanding those patterns. So here is one research with, not a research, but a paper which was published by Autodesk, which they created like 9 different data sets with exactly same statistical measurements. So their average was same, their median was same. So if you look at just as the statistics, you will find that, okay, these data sets are completely same. But when you visualize them, you can see like they're completely different how in the way they are like plotted and stuff like those. So that's why like visualization presents and helps you understand the data better, basically. Okay, so we'll start with like right now about the process of how you start with like certain information design or data visualization. I'll be using information design and data visualization slightly interchangeably. They are not exactly the same terms, but and for the convenience purposes, I'll just use them interchangeably here. Yeah, so basically, you have to ask, I would say, 4 basic questions. One is basically, who is it for? And this is very similar to, I would say, UX or UI design in that sense. So first thing is like, who is the user, or who is the audience of your visualization? So understanding that. Then comes what are you trying to visualize? So what is the data, right? Then is basically what the audience will be using the data for. And I'll come to that in detail in a bit. And the last thing is how you visualize, like what would be the outcome on the screen or on the paper or something like that, right? So when we are talking about who is your audience, so it's very similar to what you might do in, let's say, UX design. When you research your audience, you try to find out the demographics of the audience and things like those. It's very similar to that. But here you also want to know like what is quote unquote like the data literacy of the audience. Like what I mean by that is that, do they understand statistics? If I tell them that the mean of a certain data set is this, would they understand what I'm talking about? Right? Or are they non-technical people? What is the domain expertise of those of the audience? So by domain expertise, let's say if I'm doing a visualization on let's say pollution. So if the audience which is looking at that visualization, are they climate scientists, or are they like normal people like you and me who don't understand maybe the language, scientific language? So those kinds of things. So you might have to slip down the data a bit more for people like you and me who are not necessarily climate scientists, right? Why they would be using this data? So what are they like trying to just using it for gaining some information, or they want to dwell deep into it, and all those kinds of things. And also like lastly, which I would also say is the platform usage, which is more to do with like the current consumption of information which we have. Is basically, will it be shown on a newspaper or a print media? Would it be a digital media? If it's digital, then is the main target on laptops or big screens, or would it be on touch tablets and things like those? So it's in a way, I would say it's like very similar to how you would do a UX audience user research, right? Next is basically, what are you visualizing? So what data are you visualizing? And this is very important because it helps you choose a right medium or visual to visualize the data. So in a way, what you can do is that you can divide the data in like 2 broad categories. One is qualitative and another one is quantitative. So I think so the name is slightly self-explanatory, but then qualitative data is mostly like which I would say is not mathematical in terms, whereas quantitative is mathematical. Like so numbers would be quantitative. And qualitative also you can basically divide in 2 parts. One is nominal, which are like binary data in say. So like gender would be a sort of nominal data where you can have male, female, or third gender. Or pass, fail, yes, no is like nominal data, which is like can be categorized basically. And ordinal is also something which can be categorized, but it's like sequential. So small, medium, large has a sequence to it, but it's still a category. There's so if I say what is small, it would be very hard for you to say, okay, small 20 is small. So the definition of small might be different for different people. So it's basically it's like that's called an ordinal data, which is like categorical, but it's sequential in that sense. And then in quantitative, there are two types of data, which is one is discrete, which is numbers, but then they are not continuous numbers. So basically, if I say how many students in a classroom, that's a number data, but it can't be like 2.5 students in a classroom. There can be only 2 students or 3 students. There's nothing in between, right? And then the last one is continuous, which is basically your height, weight, and all those kinds of things, which can be continuous. So your weight could be 60 kg, 61 or 61.1. So it can, on the number line, it can lie anywhere. So you should, whenever like trying to visualize any data set, you should also identify what category the data set lies into, because that would help you choose the right medium for visualizing it. Like, would it be a bar chart? Would it be a scatter plot or something like that? And then the third thing is like what your audience want to do with the data. So what I mean by that is that is the main objective of the audience, or the main thing which you want to communicate with the data is, let's say, is it to find trends? Is it to find distribution? Is it to find outliers? Or is it to like show a map or something like that? So basically, you have to like ask those questions, and then you will also gauge more information about your, and that here's where the your when I said like know your audience, this is also knowing your audience also helps you identify what they would be interested in doing. Yeah, so last step which I would say is basically how do you visualize the data, right? So you have understood the data, you have identified the functions that needs to be done with the data. Now the question is, how will you visualize that data, right? And why would you do that is also a good question. I'll show you with an example. So which is basically, let's say these are just a set of numbers, right? And if I ask you like how many positives and how many negatives, it would take you a second to respond to that question, because you are counting right now and you are seeing like, okay, how many positives and how many negatives here, right? But if I just show you this and ask you like how many positives and how many negatives, then you can very quickly identify that, okay, 4 are negative and 6 are positive. So that's the power of visualizations, and that is basically us like humans being visual animals or visual beings. It's like we are sort of leveraging that power, right? And as designers, you would have to take calls like whether you do it this way or that way whenever you are like designing a visualization, because certain things are better to represent certain qualities, whereas other things are better in representing other qualities. So yeah, so basically when I was saying that certain things are better, like this is a chart which was done by Burton, who I think so in early 1900s. Is basically, he's a cartographer, so he basically used to make maps, and he basically created this thing that what qualities can be used to visualize, like what qualities are easily identifiable from others. So when he says position, what it means is that you can very easily identify psychologically, like if two things are more far apart from each other, right? So and then sizes is also very easy to identify, whereas if I say color changes, that takes a bit of a time for you. So what I mean by that is that if I give you a line of length 100 pixels and I compare it with a line of length 200 pixels, you will human brains are very good at computing that it's more or less twice the length of the first one. Whereas if I give you a red color which is 50% more brighter than another shade of red, your brain won't be able to map that thing very accurately. So that's what this list shows, that positions, we are very good at identifying which thing is closer, which thing is farther, and by how much is it farther. Same goes with length. Shapes, not so much. You still have to count stuff if you want to use like things there. Colors, it becomes even harder. And that's why in visualizations, you'll very rarely see colors used as a linear thing. That's why you will have like the most common chart which you'll see would be a bar graph where you use like the size of the bar to represent some values because it's very easily identifiable that way. And then if you remember when we were discussing about the different types of data, and then when I said that there are quantitative and qualitative, this is another research which was done by McKinley, and basically which says like what things, what parameters or what visual cues you can use to represent what data sets. So if it's a quantitative data set, a position is the most accurate way to represent it. A shape is the least accurate way to represent it. If it's like nominal, which is basically categorical, position would be the best way, but then you can use colors like hue. So let's say you can use blue for, so if you're thinking about like age groups, right? So young versus old. So if you want to do like blue and red or blue and green, then you can do blue for young and green for old. So whereas you might not be able to do that so easily with colors when it's like a sequential data, because then it becomes a bit tricky there. So these are some of the ways to like how to help you like represent the data basically. And so yeah, and basically you use those kinds of things while you're doing this. And then basically, like I said, that you also want to identify what the users want to do with the data, right? Whether they want to find outliers, whether they want to find different categories or stuff like those. And based on that, there are these tools, which this is basically from Financial Times, and it's an open source tool. You can find it like on GitHub or something. Where they have like said that, okay, if we want to find rankings, for example, that which is the tallest and then second tallest and things like those, we use a bar, like a horizontal bar graph. And then second, if that is not an option, then we try to use a vertical bar graph. If that's not an option, then we go for a scatter plot. So they have like created these like categories where you'll find like these different things which people might be interested in. So for example, if you want to communicate change over time, like how data has changed over time. So a line chart is one of the best ways to visualize that, because then the user can see the trend very easily with a line going up or down, or how is it fluctuating or things like that, right? So they have created this, it's a PDF document, it's available on GitHub. And I think so I'll share the presentation also with Ankita, so she can share it with you guys. And basically here's the link also for that. And then there's another website which does the same thing. It's a more interactive version, has I think so, more amount of visualizations which you can choose from, which is called Database Project, which I think so it's done by one of the European data visualization small studio. So this is also pretty cool because you can choose like, okay, I'm interested in different comparisons. And then you can also filter by like, I have a continuous data set, I have a quantitative data set or a qualitative data set, and they'll tell you that, okay, maybe you can use these, or these. So these are like very good introductory tools to just make sure what the visualization type you are using is appropriate for the data which you have basically. Okay, so basically that was basically how you broadly visualize data. So if, for example, if you are working in a team, mostly you will be focused on this area as designers. But let's say you want to work on your own projects. So side projects are really good for working on your own, for improving your skills and things like those, and you want to work on your own projects. So there it's a bit trickier, and I'll tell you what's the process of doing that also. That if you, let's say, don't have a statistician with you or don't have a domain expert, how do you go about doing that? And if you want to still do a visualization project as a designer, how would you sort of proceed doing that? So basically, when you do a project, right, they can be broadly categorized into two categories. One is called as explanatory, and another one is called as exploratory. And what they are is basically, so explanatory is basically something which you are explaining. So you as the data, the visualization is taking the audience, is hand-holding the audience and telling them exactly what the story is, what the data communicates, and everything like that, right? So in most cases, it would be a static data set. So, and it's basically a communication via story. So uh, the examples for that would be basically any infographics you see or any data journalistic piece if you have seen ever. So New York Times does like really good job there. Washington Post is another one. Guardian, Financial Times. These are some companies which does like really good. Um, in India, there are not many, but then there's this sort of statistical agency called as India Spends, which does good visualizations, and they write blog posts and stuff like those telling how sort of visualizations work. Yeah. So when you're talking about explanatory, it's more you have to, so you as a designer or as a person who's creating behind this visualization or story or whatever, there's a higher responsibility on your hands that you don't communicate something which is false. Whereas explanatory, you are just presenting the data, and it's up to the user what they want to get out of that data, right? Let's now go in the process of what's the difference when you're designing these two. And bear in mind, this is my process. It's not something which is set in stone. Other people have slightly different processes which they use. So I'll just be talking about how I generally start with an explanatory visualization if I'm doing something like that, right? So for me, it starts with an asking a question that which I want an answer to. So some topic which you might be interested in, something which has been like, oh, why something happens, like why X happens or why Y happens, or why something was done over other things. It starts with that kind of a question. And then once you have that question, you try to collect data which helps you answer that question. So, and I'll come with a case study which I'll explain these things more. So I'll show you an example which I did as a personal project. So I did this project, which is basically I just wanted to do a project on basically air quality in India. So basically air pollution in India. And so it started off with a question that how bad is the air in India, like the air you breathe in India, and how does it affect me personally? Or and when I say me, I don't mean like me as a person, but as anyone who's just reading this article, right? So that was the thing, that was the pivot which I was rotating this whole article on, right? Once you have that some topic which you are interested in, or the question which has been asked, right? Now you want to try to identify what are the data sources that could be used here. So here it was, okay, what's the problem of air pollution, right? So a very first data source which would come is that what is the air quality? Like what is the PM 2.5 concentration and things like those. That data is available, right? That helps me to understand how bad the air is, but then it doesn't give me any context, because I need a context. If you say that air quality is 35, I don't know if it's good or bad. So I need some context there. And again, like that's where you ask, like, how does it affect me, right? And that's when you basically start looking for other different kinds of data sources there, which is, okay, like what is the health effects of breathing the air which we have, which we breathe, right? What is the economic disadvantages of this thing? What are the impacts which it has on environment, on like my health, on my finances? So basically, this is how you basically identify the data source and try to crunch numbers there. right? And that's what I'm saying, that that's when you analyze the whole thing. And to do that, you need slight amount of understanding of the data. So you need to know how to analyze the data. So you need to know like very basics of statistics. So what is an average? When do you take an average? What is a median? When do you take a median? What is, so those kinds of things, which helps you. It's not necessarily you need to do that, but it helps you to do that, right? And once you have come up with a whole understanding that the what the problem is, then you start like designing what you want to communicate. Because as so I'm not a climate scientist or an expert in air quality or pollution, right? So I have to do a lot of research myself when I'm doing this kind of a thing, right? So that's where basically you collect the data and analyze. So that's the part where you research the things. And if you haven't researched the things, it would be very hard for you to design something or communicate something if you yourself don't know anything about it, right? So that's where basically you do that part first, and then you start doing like the designing part, which I mentioned earlier, which was like the full step, like knowing your audience and things like those. And generally it's very similar to any UI UX or any graphic design project. You do benchmarking, you do some SketchUps, mockups, and then you iterate on them, try to figure out if it's working or not. You might do a user test if you want to, if you have time or bandwidth to do that, and then you come up with the final design, right? We can go through this project in detail. I can show it to you after the whole talk is done, and if you guys are interested, right? And then how is it different from the exploratory? Like this explanatory is slightly different from exploratory thing. So the difference basically lies is that in exploratory, you don't know anything about the data yourself. You are just given the data, and you want the users to explore the data and make their own inferences and stories out of that data, right? So when you are building a dashboard, or when you are building a business intelligence tool or something like that, you are just telling the users that this has been your profit margins. Or here, when you are doing like a business intelligence tool, for example, the company will give you that, okay, these have been our profit margin for past 12 months or 24 months, right? And you are not there to tell them that whether this is good or bad. You are just there to present it to them, and they'll make a judgment whether it's good or bad, right? So that's the big difference. Whereas in explanatory, you will tell them whether it's good or bad, right? So here, the basic idea becomes like the data needs to be explored. So this, it becomes very much a task of information design as well as a UX design. It's also a UX design problem then, because you are actually creating an interface which people would be using and exploring around and playing around with it, right? And one basic thing with exploratory is that you also have to keep in mind that the data might be dynamic. What I mean by that is that it might be a real-time data. So the data could go from, so right now the data might be looking very smooth. Tomorrow it might be completely off the charts. So you might also have to take in mind when you are designing that you don't have any control of data in this case. So you'd have to design a case design a visualization or a system which takes into account those kinds of problems also, that edge cases and failure conditions and things like those. So that's what the big difference is here. So that's what I was trying to say when I said like it's dynamic. So things might break in between and stuff might happen. And that's why basically in exploratory, UI and UX actually becomes an important part of the design process. That what you will do. Like I'll show another project which I did, which I've chosen because it's of the same vein which I showed earlier, which was like the air quality. But I'll tell you what's the difference between those, like why this is exploratory and why that one was explanatory. So this was basically the same project which I did, which was on air quality, but this is basically a dashboard. where you, and I'm not telling you anything that how bad is it for you, how good is it for you. What I'm telling you is that this is your air quality currently. This has been in the past so much, and this is the air quality in other parts of the world. Now you make a judgment whatever you want to make out of it. Is it good for you or bad for you? You as a leader make a judgment what you want to make for out of it, right? So that's basically the difference here. And when you think about it, like so here, that's the thing, like what data you want to visualize comes from what users are interested in knowing, not what I want to answer, what the users would be interested in knowing, right? Then it's a real-time data. So again, it can go from anything to anything. There might be places where the data is not available. So how do you manage for those kinds of issues, right? Yeah, so, and then in explanatory, there's this thing which is, so there's this professor in university, there's a computer science professor, I don't remember the university he is in, called this Ben Schneiderman, and he gave this like idea of whenever designing a dashboard or a exploratory visualization, you should first give an overview to the users that this is what the data is. So that's an overview. Then let the users zoom in or filter out stuff. So tell them that, okay, they can choose or pick and choose. And then let them, detail on demand means is that if the users want the detail, they get the detail. So what it means is that, again, coming back to the Flipkart example, let's say if you go to the mobile page, it tells you that there are these many mobiles in the shop. You can choose from any of them. Then it lets you filter in, lets you filter as a user, right? And then when you are interested in something, you click on the mobile to see the details of that mobile. So that is detail on demand. And in visualization also, it works like that, that first you give them a bar graph or a scatter plot, let them look at if there is anything interesting. Then if they're interested in like a particular time frame, then they get to see that time frame. Otherwise, they don't, like, all, if they are interested in a particular country, they see that particular, filter out the data for that country. And other than that, if they are more interested in dwelling into the details more, they can click on that country to show that things again, right? So this was a sort of an overview. If you guys want, I can quickly go through the interactive versions of these pages to explain how these things work, because we are running slightly short of time, so it's up to you guys. And yeah, so that was basically the overview, how generally the processes of visualization works. So yeah, if you have any questions, and there are like these, some of the books and tools which you can use. So yeah, like these are some of the books and visualization tools which you can use, and these are some of the blogs if you're interested in knowing more about stuff. So these would help you there.